Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2018 Physics Paper 1 Higher Tier for the separate science physics. This question relates to the topic on energy. However, the first question, 10.1, actually relates to particle model of matter because density is actually taught in a different topic. In this question, they've actually combined the energy topic and the particle model of matter topic as well. So we should still be able to answer this question here because it's a calculation. At a particular wind speed, a volume, which is V, of 2.3 times 10 to the power 4 meter cube of air passes the blade each second. The density, the symbol for density is rho, of air is 1.2 kilogram per meter cube. Calculate the mass, m, of air passing the blades per second. So, using the equation for density, which is rho equals mass divided by the volume. So, if we rearrange it, mass equals the density multiplied by the volume. Density is 1.2 multiplied by the volume, which is 2.3 times 10 to the power 4. So using our calculator, 1.2 multiplied by 2.3 to the power of 4 equals 27,600 kilograms. So 27,600 kilograms. You can write it in standard form, 2.76 times 10 to the power 4 kilograms, but you can leave it as it is. Question 10.2. The power output of the turbine is directly proportional to the kinetic energy, or EK, of the air passing the blade each second. Describe the effect of the power output when the wind speed is halved. So speed, if it's halved, what happens to the power output? Now, you have to link two equations here. The equation for power, remember the equation for power is energy divided by time. Now, since the equation power equals energy divided by time, we can write that as power output. Now, here we are talking about kinetic energy. So, kinetic energy divided by per second. So, the power output is the kinetic energy per second. So, what happens to the power output? What happens to this value when the speed is decreased? We're talking about per second anyway. So, you need to refer back to the other equation for kinetic energy. So, if I write the kinetic energy equation, E K for kinetic energy is half mv squared. Now, if you double the mass, the kinetic energy doubles. If you double the speed, it actually increases by a factor of 4 or quadruples. Here they're asking what happens if it is halved. So if you halve the mass, first of all, the kinetic energy gets reduced by half. Right? So describe the speed of the effect on the power output when the wind speed is halved. If the wind speed is halved, the amount of air that is passing through will also be halved. So the mass is going to be halved. Mass is going to be halved, and the wind speed is also halved. Right? So if you double the speed, it increases by a factor of 4. If you halve the speed, it will reduce by a factor of 4. So here's the written answer. when the wind speed is halved, then the mass of air passing through the turbine blades will be halved, right? Which decreases the kinetic energy by a factor of 2. So that's 2 points. This is key. It reduces it by a factor of 2. It also decreases the kinetic energy by a factor of 4. Right? Now, together, you need to multiply to see what happens to the overall power. This reduces the overall power output to decrease, or should say this causes the overall power, right? Sorry. Causes the overall power output to decrease by a factor of 8. That's a hard question. Question 10.3. At a different wind speed, the wind turbine has a power output of 388 kilowatts. The mass of air passing, so the mass is m, of air passing through the wind turbine each second is 13,800 kilogram. Because it's per second, right? Remember, power equals energy divided by the time. So that's 388 kilowatts is the same as saying 388, because it's kilo, multiply that by 1000, 388,000 joules per second. So that's energy divided by the time. So same way of saying kilowatts. Calculate the speed, which is V, of the air passing through the blade in each second. So that's how much the energy is in every second. Assume that the process is 100% efficient. So using the equation, EK for kinetic energy equals half mv squared. That's 388,000 equals half times m times, oops, I should know the mass. Let me get rid of that. So should be able to use the value for the mass there. The mass is 13,800 multiplied by v squared. Rearranging the equation, v is equal to the root of 2 times 388,000 divided by 13,800. So let's use the calculator. 2 multiplied by 388,000, that is 776,000. Divide that by 13,800. That gives me 56.23. Now, in order to find the speed, I need to find the square root of that. So, square root of 56.23 gives me 7.49. So round that off to 7.5. So 7.49 498, round that to 7.5 meters per second. That's the end of question number 10. I'll see you in the next video. Thank you.